Hello friends, welcome in this video tutorial series of settlement model, and in this video we'll talk about the hotspot analysis using this Getis-Ord Gi star statistic. And down is something about me. I'm Dr. Zubairul Islam, working in the Department of Geography, Adigrad University. There are two types of tools available in ArcGIS for hotspot analysis. One is hotspot analysis manually, and the second is optimized hotspot analysis. As in the optimized hotspot analysis, a tool read our data characteristics and gives us optimized result automatically. But in hotspot analysis, we have to give the parameters manually. So let's see. So friends, I'm open with my software and I have the data at left hand side in the table of content, and the right hand side is the R toolbox. And our task is the hotspot analysis. Before we go for analysis, there are some very important points which we must know. The first thing is that we have to be sure that whether the input feature class contain at least 30 features, because results are not reliable with less than 30 features. So in my case, if I have the urban centers, and the total urban centers are given are 561. And but what I will do is I will take this urban centers data at zone level. So in that case also, if you will see my zones, then you will find that there are 67 zones in Ethiopia, maybe more or less, but the data I have is, in this data 67 zones are given. So this is fine that I have more than 30 features. The second thing which we have to be clear is that when you will click on hotspot analysis, the conceptualization of these spatial relationships, by default it's a fixed distance band, because this method is the best for hotspot analysis. But what I will do is I will get the spatial weight from the file, because to explain the hotspot analysis it is important to take this the spatial weight from the file. So but if you are doing your analysis, you have to be sure that is the conceptualization of the spatial relationships you are selected is appropriate or not. As I have already mentioned that for this tool the fixed distance band method is recommended. And fixed distance band, how you will know that what is the distance, what distance you should give. So for that very purpose there is you know there is we can say that if you want uh, especially what happens if your data is skewed and more skewed, then you should have at least 8 neighbors or more than 8 neighbors. So to calculate the distance band from your neighbor count tool, it can be used to find the average distance. If you are giving the 8 neighbors, then you can what average distance should be there. Then for that very purpose you can go to the utilities, calculate distance band from neighbors. You can choose this one. If I need the zones and I need 8 neighbors, at least 8 neighbors, okay, then you can do it. Okay, and here in the message box you will find the distance. The minimum distance of 8 neighbor means 8 zone is around 106 kilometer, and average distance is 209 and maximum distance is 603. So if you are giving the distance 603 kilometer or 603,000 603,256 meter, then it will be highly generalized. You cannot your hotspots will be highly generalized, not very much specific. And if you are giving 209, it's okay, but this is the way you can do it in your analysis. And it is very important to know that what you are going to do and what is your analysis field. So the data I have, as I told you, this is the urban data, and there are around 600 these centers, and there are I have the data, different types of data of each urban center. Uh, but with the help of this tool, what I will find is I will find whether high or low values cluster spatially. So of course this is not the point data. If you have the point data also, then what you can do is, because the field containing those values is your analysis field, any analysis, the values. So for point incident data, however, you may be more interested in assessing the incident intensity than in analyzing the spatial clustering for any particular value associated with incidence. Okay, so for intensity, uh, you know, uh, you can use the point data. Uh, what happened here is it will be better if you are taking some polygon features, and here I will take the zones. You may take the Veredas also, because if the number of features are more, your results will be better. And you can take the Kavile also. So here I'm taking the zone, and if I want to take these the urban centers information, if I want to transfer to the polygon, if I want to aggregate it to the polygon, then there are several ways we can do that. So if you have the polygon feature for your study area, as I have these zones, then I can use the spatial join tool to count the number of events in each polygon. The resultant field, it containing the number of events in each polygon, becomes the input field for the analysis. So where you will find this one? You can find it here. So here is the spatial join under overlay, and okay, thereafter the zone data is here, and the join feature is this urban centers, and there are many options, but I'm taking the intersect. Okay, and you can do it. Okay, then after that you will get a file. Okay, I have already got a file, and my file is here, and at zone level I have my data, and when I see the data, actually the data is much skewed in case of Ethiopia. relating to the urban centers, because the socioeconomic data, if you see, the population is highly skewed, because in some of the zones like Addis, there is high population compared to another zones. For instance, you can see this one population. If you will see the population data, statistics, then it is highly skewed, because Addis Ababa more urban population than another urban centers. Similarly, if I will take the built-up area also, the GDP data also, the socio-economic data is much skewed, and your data if is highly skewed, then you know the results may not be much reliable unless you are not aggregating, giving some fixed distance. But if I am giving the fixed distance also, then also the another uh, it is not giving the hotspot in another areas. So I took the air quality data, and here I will analyze the data which is uh, which is the particulate matters of 2.5 micrometer per cubic meter of air. So here you can see that data, that is maybe, yeah, this one, yeah, here the data is not much skewed, because the particulate matters are found in all regions, but in some of the regions may be higher. So I am giving this data here, particulate matter, for my analysis to find the hotspots. So as I have already discussed, under the spatial statistics tool, mapping cluster and hot spot analysis, the recommended is fixed distance band. I can give that also, but here, because I have to explain this exercise in depth, so I will take the get spatial weight from the file, because from the file I can take the feature, any feature which is getting the weight from its neighboring feature. Then thereafter, what is the calculation behind the hotspot analysis, we can understand very well. So I will make the spatial weight from file here. For that, what I will do is I will take the, again, utilities. Okay, it is found in generate spatial weight matrix here. Generate spatial weight matrix. My input file is ETT. Here is, yeah, here it is, ETT. And I have to give some unique field. Here I'm giving object ID 1 and output. Where do you want your spatial weight matrix file? Here I can give the name like maybe JS exercise. Then conceptualization of here I can give the nearest neighbors, how many neighbors I want. I'm giving here 8 neighbors. Okay, thereafter I will do it. Okay, then it has already generated the file. Then if I am going mapping clusters, thereafter hotspot analysis, and here I can give ETT and input field I can give, but before that, okay, let me, this is the particulate method, air quality parameter 2014, and here I can give the get spatial weight file, okay, from the file. Then I can give here that matrix, but I want to know that is this, what file is this, because by the extension of WSWM, sorry, .swm, you cannot read this file, but just to explain you, I wanna read it, okay. I wanna show you that what is this, what file is this. So just to convert the spatial matrix file to the table, what I will do, I will take the file here and my output file will be this. Then do it okay. It is completed, close it, and my file is here, GIS. And now you can see that if object ID is 22, then this 22 is getting the weight from 23, 36, 57, 31, 18, 40. Let's see what is object ID 22. So to see the object ID 22, let's make else 22. So this feature is getting the weight from from 23 from its neighbors, okay, from 23, from 36, 57, 31, 18, 45, nearest 8 neighbors, okay, 45, then 53, then 32. Here is 32. So 22 is getting the weight from all its neighbors, and the neighbors are these. What is the weight? 0.125. Okay, thereafter, similarly, another features also getting weight, like 44 is also getting the weight from 44, maybe here and there. So you can see all these things will be clear to you, that which feature is getting weight from which neighbors, okay, what is their IDs. So this is the way you can go in depth of your analysis. You can look at that what is going on at the background of the analysis. So the next we are ready and we can use the tool, that is the hotspot analysis tool. Here it is. I will click this one, hot analysis. I will give my feature class. I will give my field. My field is the concentration of particulate matter 2014, and the conceptualization of a spatial relationship will be from the get a spatial weight from the file, and I have a file, the name is GIS. Open it, and thereafter you can make it okay. So we have got our result, and our result presents that the upper region, including the eastern part of Tigray, southern part of Tigray, and eastern part of northeastern part of Amhara region, and yeah, this is the hot spot of particulate matter of 2.5 micrometer per cubic meter. Means here this is the concentration, and this is you are here at 99% confidence level. But in the southern Ethiopia, there is less concentration of particulate matter. So when you will see the result here given, open attribute table, here you will find the GI bin. Here, this is the GI bin, and GI bin field identifies the statistically significant hot spot and cold spot. Okay, it will identify hot spot and cold spot based on the Z value and P value. Okay, so feature in +3 or -3 bin reflect statistical significant with a 99% confidence. Okay, so here these are the features which are having the cold spot, and if you will see just opposite of it, +3, these are the features which are having the hot spot. So if it is plus or -3, it reflects the statistical significance with 99% confidence. Okay, and why this is so? Because of the p value. Okay, because of the p value is very small here. P value for 99% you can understand it should be less than 0.001. So it is less than 0.001, and it should have above 3 or above 3 Z score. If it is plus or -2 bins, it reflects a 95% confidence level. If it is +-1 bin, +-1 bin, it reflects a 90% confidence level. And the clustering of the feature in bin 0 is not statistically significant, because here p value you can see is more than 0.1. These zeros shows the statistically not significant. So this is a very important tool, and why this is important for us, because whenever you see a spatial structure such as clustering in the landscape, then what does it mean? You are seeing evidence of some underlying spatial processes at work, and as a geographer or GIS analyst, this is often what you are most interested in. So you can see that why this area is having as much particulate matter of 2.5 micrometer size. Another interesting thing to note is, if you will see the data, okay, let me show you the data here. Okay, this is the data. Let me level it. Why I'm doing like this? Because I want to show you that a feature with a higher value is interesting, but may not be statistically significant hotspot here. This is our data. So as you can see here, as you can see here, 35 is the hotspot, 32 is also hotspot, but 33 is not the hotspot. Why? Because around 33, which is getting the data, which is getting the value from its neighboring, is having the lower values. Because to be a statistically significant hotspot, a feature will have a higher value, and it should be surrounded by other features with a higher value as well. Okay, this is the condition. So in this case, Y33 is not a hotspot because it is not surrounded with higher values. Maybe this feature is giving its lowering its weight. So with the hotspot, the here and there, if some features are having higher values, then this tool will ignore those values, because those higher values, if these values are surrounded with lower values, it will not give you as a hotspot. So this thing is very interesting to note. Okay, and the next in the next we will see what is the formula used to calculate these hotspot and how this formula works here. uh, there are all the features in the formula, all the features and the local features and the individual features are involved. So we'll see the formula for our better understanding. Friends, this is the formula which was used for hotspot analysis, and this is known as Getis-Ord local statistic. Okay, and it is pronounced as GI star statistic. And as we have already discussed, there are three things involved here. What are these three things? This is the weight of 8 features, as you can see here. For example, you take the example of 1,5, and if you will see the 1,5 in your weight matrix file, so 1,5 is getting the weight here. This is 1,5. So 1,5 is getting the weight from 13, 12, 6, 11, 9, 14, 33 and 5. So these are the features which are giving weight to the feature ID 15. Okay, so in the formula you can see here, this is the weight part. Okay, and there is some individual part also which you can see like this, and there is a global mean also here. This is the mean part. Again, this is the weight, sum of weight, and weight, total number of feature minus 1, and this S actually here is important one. S is being calculated by, here you can see this is the S part. So in the S part, it is the all global part, all the features here. These are the features. These are the features. And in the features, you can see here, these are the features. Okay, this is the mean of the features, 26.67. This is the mean here. All features you will make a square, and thereafter you will make a sum divided by number of features, then this S will come. And in the upper part, this is more related with the local, the hot or cold spot area. If you will see, the upper part is more the weighted part or local part. So if weighted or local part is having, or if it is larger than down part, of course you will getting, if it is double, you will see this is equal to here, because as you can read it, GI star statistic is a z-score, so no further calculations are required. So you can Google about this statistic, and there is very good help given by ISRI help program. You can read further for better understanding. So this was all about the hotspot analysis in GIS. Now we'll talk about the optimized hotspot analysis. As we have seen that in the hotspot analysis, there were many things we were concerned. We were concerned about the conceptualization of spatial analysis. If it is a fixed distance band, then what distance should be given? All these things, sometimes we do not understand that what value we should give, and what the what should be the conceptualization of spatial uh, distance. So there is I can say there is a shortcut for that, and with optimized hotspot analysis, uh, the what happens actually, the tool, it evaluates the characteristics of input features class to produce the optimal result. With the help of this tool, there is no need of giving all these what is the spatial relationship and all. So we'll see optimized hotspot analysis. So as you can see that this is the result of our previous exercise. Now we'll practice the optimized hotspot analysis. Uh, Here is the tool. We'll click this one, and the input feature, output feature analysis field. Let me show you one thing interesting is ETT. This is the last data which I have. So this green point will come. The graying point will indicate that here you have to give the attribute value. Okay, but this optimized hotspot analysis is very good for incident data also. What is incident data? Incident data are the points representing the events, okay, like crime, traffic accident, or objects like trees, stores, where your focus is on presence or absence rather than a measured attribute value. So, in the incident data or the objects, only numbers are enough. There is no need of giving the attribute value. So, that way also you can go for hotspot analysis. It will make the fishnet, and within each the square, it will count the numbers only. So if I give this point data, then this green point will go, then it is not required. If I will give this one, no need, direct we can go for analysis. The only thing is that it will ask you the bounding polygons, defining where incidents are possible. That is, you can give the zones or regions or corridors. So the first thing, we have to understand is that with this tool, what this tool do, it evaluates the characteristics of the input feature to produce the optimal result. So this is automatic, means automatically it do so many things and it gives you the optimal result. So first let's see the optimized hotspot analysis with polygon data with attribute value. Here I am giving the same value which we have done analysis before. So when you will give the polygon and attribute value, this bounding polygon defining option will be unhighlighted, then do it OK. All these results, what are the parameters used by the software, or what are the okay, it is written here, you can read also. Okay, the distance band was used around 493 kilometer, and it means it has gone to highly generalized. And the properties of your attributes are: minimum is this, maximum is this, mean is this, standard deviation is this. And it got 63 valid input features. If there are the features which have some problem, it will eliminate those features. Okay, then let's see the result. And now here you can see that this tool has made a larger hotspot than previous one. And if we see the attribute value here, we can evaluate our result. And because what happens with optimized hotspot analysis, this tool read your data characteristics. So let's see. So these are the values here. The normal hotspot analysis is giving you a hotspot, no doubt, this one also, but it says that you are 95% confidence that it may be the hotspot, but in this case they are 99% sure that this is the hotspot. And thereafter you can see the value also. All these values are 33, 30, 30, 31, 30, 36. So If we see our data attribute value, then it seems that this part should also be included, and the same thing has been done by the optimized hotspot analysis tool. So, and this optimized hotspot analysis tool, uh, it used the parameters derived from the characteristics of your data, and these parameters are written in the result window as we have seen before. And ArcGIS has mentioned very well that this tool works similar to the way that the automatic setting on the digital camera. Like if we are using normal hotspot tool without optimized, then it works manually. Okay, you have to give the conceptualization of spatial relationship as well as distance band also. You can make the, you have to give the how many neighbors you need, but in this one, this tool is similar to the way that this tool is similar to the way that the automatic setting on the digital camera will use the lighting and subject versus ground reading to determine an appropriate aperture, shutter speed, focus. Uh, so this is what automatic tool to create the hotspot. And this tool interrogates your data to obtain the setting that will yield optimum, hotspot results. So here we were using the polygon, and the next one, let's see if we take the incident data or some. Here we will not give the attribute value. It will use the, here no need of analysis field because just we have to give the polygons, and what it will do, it will make the fishnet polygons. If you want another hexagon aggregate, then you can give these also. Here I'm giving the fishnet polygon. So in each fishnet polygon, how many incident endpoints are there? Based on that information, it will give you the hotspot. Do it okay. And naturally, where the urban centers are more, there will be hotspot. Here I'm not giving the attribute value. And the result, you can see the parameters will be written in the result window here. The total study area is around this one, 1.1 million square kilometer. And in the polygon minimum is 0, maximum only the numbers, okay. And total fishnets are 578, like this. And the same information you can see here also, the geoprocessing results, and here this is the messages. Here also you can see the same information. So here basically there was no attribute value, just simple the concentration or the the presence of these points only, the incidence. So naturally this area is highly more, here the density is high, so this is the larger hotspot of the incidence. And suppose this polygon is not counted as the hotspot. Why? Because the surrounding fishnets are not having the points. So this is the way we can use the optimized hotspot analysis. Okay, and this video, I hope it will help you to know about this hotspot analysis. Of course, it is not covering all the parts. Once you will practice yourself, then you can explore many more things. And if you like this video, please hit the like button, or if you have not subscribed the channel, please subscribe my channel. And thanks for watching, and thanks for listening.